information. If you didn't see in the chat, this session will be recorded so that it can be presented on our website at a later date. So for that reason, your camera and microphones are muted, but please do feel free to input questions or comments in the chat as we go through the presentation. Good morning and welcome to WSPS Safety Connection. Today we will be discussing confined space and asking the question, what are we getting into? My name is Troy Nell, a consultant with WSPS, and I will be your host for today. Your speaker for today is Mr. Dale Wales. Dale is a specialized consultant for confined spaces at Workplace Safety and Prevention Services with over 30 years experience in occupational health and safety, emergency response, and emergency management. Prior to joining WSPS, Dale worked in municipal and industrial emergency response, rescue in Ontario, Nunavut, and most recently in Panama, directing a team of 30 full-time and 120 volunteer responders in a 35,000 hectare copper mine with about 15,000 employees. He specializes in confined space and technical rescue, having developed several hundred confined space hazard assessments, entry plans, and rescue plans throughout Canada and Panama. Dale has managed and served on emergency response teams responding to confined space, high-angle rescue, hazardous materials, fire and medical emergencies. Dale is also qualified under the NFPA standards as a fire officer, a firefighter, confined space rescue technician, rope rescue technician, hazardous materials technician, and industrial firefighter, and has also completed confined space advanced training. As we go through our material today, our goals include staying in touch and virtually connecting with industry peers, providing an opportunity to attend the session from your personal workspace, and to facilitate an exchange of best practices within a variety of sectors and organizations. One of our goals is to learn, share, and discover what is of value to you. Okay, I see some questions about the audio. So if you are having issues, please log back out and log back in. Thank you. So we are going to be discussing some key elements of the confined space, including rescue plans, identification of confined spaces, and some best practices for entries and rescues. So with that being said, I will hand it over to our speaker for today. Welcome, Dale.
Thanks, Troy. Can we move on to the next slide, please? So we're going to get started today and just find out what your level of understanding is for Ontario Regulation 63205, the regulation on confined spaces. So if you could just fill out the poll there and let us know what your level of understanding is, and it's going to help us proceed through the presentation today. Okay, so it looks like we've got a little bit of very low. We've got some low. Moderate is our is where we are, about the middle of the pack here. Okay, now if we can close that down, Troy, and we'll get rolling here. Okay, so basically what we need to do is, why do we need to bother about confined spaces? You know, not only is it a sense of moral, your morals and preservation of life, but it's also law. And as with most laws in anywhere, it's been written in blood. And as we go through this, you're going to find out how and why these laws have came into effect and the importance of working to them. Can we go to the next, please? So we are getting into basically stiff penalties for non-appliance. So Workplace Safety and Prevention Services really likes to live up to our name. We want to make sure that we're preventing any injuries or problems that could occur while you're doing work. And for the most part, a majority of our of people follow those rules, those regulations. But for those that don't, there are some stiff penalties for non-compliance. So really, if you contravene the Act, the Health and Safety Act, you could be subjected as a employee or even as a supervisor. You could be liable of a fine up to $100,000 or imprisonment of not more than a year, or both. And if a corporation is convicted under an offense, the maximum fine could be $1.5 million as not provided therein. And next, please. So according to NIOSH, we've had in between 1980 and 1989, and these are old statistics, they're kind of tough to come across, but in the US, there was 670 fatalities and 585 separate confined space incidents in a 10-year period. Almost 60% of those people who died were would-be rescuers. And let's get a little closer to home, British Columbia, the period from 89 to 2008, there were 27 deaths related to confined spaces. 7 of those deaths were would-be rescuers. And across Canada, between 2011 and 2015, there was almost 12,000 lost time injuries. There were 14 fatalities in confined spaces, and 8 were would-be rescuers. Let's move on to the next one, please. So just a little case study. January 27th, 2017, ProClean Washing Services ended up having a fatality at their workplace, and they were fined $105,000. There was 2 employees cleaning out a tanker that was contained nitrogen. One employee left, and when he returned, he found the other employee in the tank. That employee died on the scene from inert gas asphyxiation. So the nitrogen that was in that tank displaced the oxygen, and it caused a fatality. And we're going to talk about how we can prevent those from happening. So can we move on to the next one, please, Troy? So why do people die in confined spaces? Okay, we haven't tested the space. We haven't tested the atmosphere in a space, and we're going to find out why that's important here in a bit. We're assuming the space is okay because last time we checked it, it was great. Not checking welding hoses for leaks. So if you're introducing cutting and welding into a confined space, got to make sure there's no leaks happening. If you have a acetylene leak on a cutting torch, you're going to be displacing the oxygen and presenting a explosive atmosphere. Or if the oxygen line is leaking, you're going to introduce high levels of oxygens in that space, which is also a hazard. Not ventilating, not planning for rescue. My big thing is we never go into a space unless we know exactly how we're getting that person out in any condition. Not considering the effects of disturbing the contents. So you're walking around in the space, you're stirring up some of the sludge in the bottom. What are all those cool gases that are going to be coming up, displacing oxygen and causing you harm. And not considering nearby activities or operations. For example, if you're in a maintenance hole doing some work underground, you've got a vehicle parked beside the space running, carbon monoxide is being produced from that vehicle. It's going right down into the space, displacing the oxygen. So next, please, Troy. So, poll number 2, what is your role in confined space entry? And there's 6 of them listed there, and what would yours be? Okay. All right, let's move on from that one. And we're going to talk about what the structure of legislation looks like in Ontario. So the overreaching confined space regulation is the Occupational Health and Safety Act of Ontario. And from the Act, we have regulations, and those regulations are identified in the Act, which makes them law. So we have one of the first regulations is Regulation 851, dealing with industrial establishments. Regulation 63205 deals with confined spaces, and Regulation 833, control of exposure to biological or chemical agents. So those are the acts, the regulations that when a Ministry of Labor inspector comes on scene, that's what he's measuring your confined space work to. Now, there are also standards that are out there. They don't have any legal authority unless referenced. So a good example of that is NFPA 1006 1670, which deals with technical rescue. It's certifying you in the use of ropes, recovery equipment, and that kind of thing. There's also the Ministry of Labor Confined Spaces Guideline, and that is in place to basically break down what the Act and the regulations is saying. And we have CSA Z1006 on confined spaces. New version of that just came out in August, or will be coming out very soon. And although they have no legal authority, if these standards are referenced in a regulation or an act, they do become law. And we also have the CSA standard on respirators, full body harnesses, and the types of equipment that we use. So some of the other ones that are out there, like Regulation 851, is dealing with isolating and controlling energy sources, and Regulation 833 talks about the control of exposure to biological and chemical agents, and that's where we obtain our threshold limit values. Okay, and move on to the next, please, Troy. So what is a confined space? 3 things have to happen for a space to be a confined space. Okay, it has to be fully or partially enclosed, that is not designed and constructed for continuous human occupancy, in which atmospheric hazards may occur because of its construction, location, or contents, or because of the work that's being done in it. Okay, so let's move on to the next slide. And so let's talk about space being fully or partially enclosed. All right, you're probably all in a room right now, and you're going to be in a room that is fully or partially enclosed. And hopefully the room that you're in has been designed and constructed for continuous human occupancy. That means it's going to have lights, it's going to have ventilation. If you're in a home office right now, should be smoke detectors in there, carbon monoxide detectors. If you're in a workplace, those things may also be present, okay, because that is what's needed for continuous human occupancy. And it also needs to be built to a current building code. So let's talk about atmospheric hazards may occur because of its construction location or contents or because of the work that's being done in it. So one of the things that gets overlooked occasionally in confined spaces is things that are happening in that confined space. So we've got a bunch of, we've got a cement cistern that's got a bunch of metal pipes in it, metal cased pumps, and we've got rusting and corrosion occurring. When that rust and corrosion is occurring, it's consuming the oxygen in that space. If that space has been closed up for a certain amount of time that there could consume the oxygen, there's no way that you would want to put a person into a space without oxygen. So we have to address that and control some of those hazards. So even though we've controlled the hazards, we're not taking away the fact that this is a confined space. So we'll go on to the next slide, please. So what's an atmospheric hazard? An atmospheric hazard is an oxygen content of less than 19.5% oxygen and more than 23% oxygen by volume. So 19.5%, now we've got corrosion happening in that space, consuming the oxygen, and it drops it down low. We have to have a way of testing that, and we'll talk about that in a bit. And what about the 23% oxygen by volume? Remember I talked about the cutting torch being lowered into a space or put into a space with a leaking hose. That oxygen hose is leaking. That's 100% oxygen in that tank. And now you're introducing 100% oxygen to that space. And it's going to make things that are flammable more flammable. And it can even take something that is considered to be a combustible product to a point where it could become flammable because the oxygen has changed the atmosphere that much. So atmospheric contaminants that are out there, we've got gases, we've got vapors, fumes, dust, dust in agriculture could result in explosions. Dust in food processing can have the same effect. Mists. I have in the past looked at a fire investigation on a vehicle and found that the fire was started by antifreeze in the vehicle, and that antifreeze was atomized and went up against a hot surface and burned back to its source. Started the combustibles in the engine compartment on fire and started the vehicle on fire. So mists can be something that can be an atmospheric contaminant. So the atmospheric contaminants result in acute health effects, and they can pose an immediate threat to life or interfere with the person's ability to escape unaided from a confined space. So that's a very important aspect, is whenever someone is going into a confined space, we want to make sure that we can get them out. Okay, next, please. So we have to identify those confined spaces, and that's why you see these confined space stickers on some of the spaces in your workplace. So you can only enter a confined space in Ontario by filling out a confined space permit, and we'll talk about those as we go along here. But we have to identify those spaces in a certain way. So we can go on to the next slide, please, Troy. So we're going to do a confined space hazard assessment. And that hazard assessment is basically going to We're going to collect the information on the space. We're going to record it. We're going to talk about what that space does, what it's meant to do, and how it works. And we also need to know, are we going into this space to do work, or are we going into the space to inspect? So when you're doing a hazard assessment, your hazard assessment is going to be based on the space and the work that goes on in it. And one of the first things that we're going to do is ask those three questions. Fully or partially enclosed? Is it not designed for continuous human occupancy? And could there be an atmospheric hazard? Okay, go on to the next, please. Okay, and we also have to make sure that all of those spaces are inventoried. So you have an inventory list of your confined spaces so that you can simply share this with employees and let them know that these are the confined spaces that we have, this is where they are, and this is what we have to do if we need to do work in those. And we're going to go along with those, talk about those more as we go along. And next, please, Troy. Okay, so we gave you the definition there. So it's fully or partially enclosed. Is it not designed for continuous human occupancy? And could an atmospheric hazard occur? And let's see some examples in the poll here of what your spaces are. Okay, we've got partially enclosed, waste tanks, ovens, yes. Okay. Boilers, perfect. Compactor, crawl space under units, tunnels. Okay. Tanks, hydro vault, that's a very good one. Okay, underground tank, inspection tunnels, compactor. Lots of them there. Okay. Access chambers, sump pump pit, yes. Manure pits, perfect. Fermentation tanks, exactly. Especially when you get into wineries, there is all the tanks that they use, those are all confined spaces. Wine tanks, drain pits, waste pits, good. All right. Okay, let's move on to the next. Okay. Gotta get rid of that. Okay. Crown of power pass. Yes, very well. Very good. Okay, so here is some basic configurations. Okay, we've got tanks with several openings. We can have a open top pit. We can have a enter trapping configuration, or it's converging into different angles and spaces. Piping or tubing, we talked about those with the tunnels. Could be a complex configuration. Let's think about the road tankers going down the road. Some of those are baffled inside, and if someone has to go in and do an inspection on those tanks, they're going into a confined space. And on the bottom as well, you can see how various levels and layers of a baffled vertical space can go. Okay, let's do the next slide, please, Troy. So we talked about all the things that we need to have in place to do confined space work, but one of the first things that we have to have in place is a confined space program. Okay, and that program is going to lay out the rules, the policy of the employer dealing with confined spaces. Okay, so it talks about who is competent to do confined space hazard assessments and who is competent to make entries, and it lays out all of the definitions that are found when dealing with confined space work. So we have to go through, assess the hazards, implement controls of those hazards when we are looking at that confined space. Okay, sorry, let me take a step back. Let's say the answer is it is not a confined space. Even though you're working in a space that, let's say you are going into a space that is fully or partially enclosed, and it could have an atmospheric hazard, but it's designed for continuous human occupancy, it's not a confined space. With that being said, we still have to have a way of making sure that person is working safely, and we have a way to get them out in the event of an emergency. Okay, so the confined space entry program, if you do have a confined space, is going to contain 6 areas. And the first area we're going to talk about is a coordination document, and the method that we're going to use to recognize the hazards, recognize the space. We're going to assess the hazards, put an entry plan in place, put a rescue plan in place. We're going to train using all of those documents and using some confined spaces as well, because just because you've taken a confined space awareness course doesn't really make you competent to hop into that space. You need to be trained on how to get into that space and do the work, just like we do with any other job that we do. And there has to be a permit system in place when dealing with those confined spaces. And the goal of this whole thing at the end of the day, the reason we get up in the morning and go to work is to get home safely to our family at the end of the day. Okay, next please, Troy. So the confined space program must provide a method for recognizing each confined space, how we're going to assess those hazards, the development of one or more plans. So for example, the plan would be if you are going in to do an inspection, you're going to have an entry plan and dealing with the hazards, controlling the hazards to the best of your ability when you're going in to do an inspection. Let's say we're going into that space to do some hot work now. We need to have a different plan when we're doing hot work in that space than we do when we're simply going in just to look around. There also has to be a method for training the workers and an entry permit system. And next, please, Troy. So this is basically what a confined space program is going to look like. If you see at the bottom of the screen there, you see it says page 1 of 14. I'm not going to go through all 14 pages, but there is very important, there's very important information contained in that, and it is basically laying out how we're going to work within confined spaces. Next, please. So a confined space program has to be developed and implemented. The employer has a duty to ensure the program is adequate, provide a copy to any other workers, employer of workers who may perform work in the space, and ensure the program is available to every worker that performs work in or near a confined space. Next, please, Chad or Troy. Okay, so what do you do if you have multiple employers? Okay, well, you may have contractors coming in. You may have a situation where, you know what, my company does not enter confined spaces. We're going to contract all the work out. Okay, so if that's what you're going to do, if you have a company that comes in and does the inspections, the cleaning or the repairs, you need to decide who is going to be the lead employer or constructor and prepare a coordination document. The document has to be provided to each employer, their health and safety reps, and it looks something like the next slide, please, Troy. So it's going to lay out who is responsible for what. A lot of our clients will use this document if they're going through an RFP process on confined space work. So they'll include this, and they'll fill out what their responsibilities are going to be and what the contractor's responsibilities are going to be, and it can involve multiple contractors. Okay, so that is our multiple employee coordination document. And let's move on to the next one, please. So confined space training, and this is a question we get asked a lot. We need to have confined space training. Can you come in and do confined space training? And one of the questions that we'll ask is, of course we can do that for you. And we'd really like to help you out with this. So can you share your confined space program with us? And the training is really one of the final steps in the confined space program work, because it has to be, you have to have all of the information in place before you go through and do the training. So we have to have general confined space training, and that one's fine. Take that one right off the bat, and so you can learn about the confined spaces and the laws, the regulations, and the best practices that are out there. Going to put a plan in place, do plan-specific training on your spaces, and on-site rescue procedures and the equipment that you need to do, okay? And the equipment you need to use. So an example of that is, so you've got a davit arm set up with a SRL with a recovery unit on it, and you've got that set up over your confined space. Your worker puts on a harness and connects to the SRL with the recovery or the winch, and into the space they go. Questions arise to me on that is, has a person been trained in how the davit arm works? Do they know how the SRL with recovery works? Have they been trained on how to use the harnesses? And is that space more than, would it be considered working at heights in that space? So if you're working at, even if you're going below ground, you may have the need to have working at heights training to enter that confined space, okay? And another requirement is CPR first aid trained. So you need to have at least one person who is not entering the space trained in CPR and first aid, okay? And so I talked about, depending on the space, fall protection, and what if we're going into a space that we have to inert to make it safe to enter? Now we need some respiratory protection for the worker that's entering the space. Maybe they need to use an SCBA or a supplied air breathing apparatus to enter that space. So all of those things come into play when you are dealing with confined space training. Okay, and let's move on to the next one. So before any worker enters the confined space, the confined space hazard assessment has to be in writing, and it's going to consider hazards due to its design, construction, location, or use of the contents in the space, and hazards that may develop while the work is being done inside the confined space. So I saw a note in the chat go by where someone was saying, okay, we have a space that has no atmospheric hazards, it's not a confined space. But now we're going to go into that space and we're going to start welding supports in that space. We just made that a confined space by the work that's being done inside of there. So you always have to consider, even though the place I'm working is not a confined space, the work that I'm doing may make that a confined space. All right. So let's go on to the next slide, please. So here we've got a couple of pictures of different confined spaces. On the left is presenting a lot more hazards than we have in the picture on the right. On the left, we've got slip, trip, and fall hazards. We've got rounded bottoms on the bottom of the tanks. All different kinds of openings, sizes of openings. What's in those tanks? I have no idea what's in those. On the right, very clean, very neat area. And you can see it doesn't have the same slip, trip, fall hazards. It doesn't have the overhead hazards or the things that the piping and everything that runs underneath. Okay, and we'll go on to next, please. So we have to identify the hazards, and there is 6 listed here that are that we look at while we're doing our hazard assessments. And the first one that we look at is always the atmospheric hazards. Okay, so we're going to look at the atmospheric hazards and we're going to list those. And the next thing that we're going to look at is, what is the chemical hazards in there? Is there any chemicals that could affect us? Is there biological hazards? What about going into a space where it is a space that maybe you have to lean in head first and you can't get your all of your body in? If you went in feet first, you couldn't do the work because the space is too small around. So you have to think about those when you are putting someone into those spaces, that we have to be aware of that. Psychosocial, are you afraid of confined spaces? Are you claustrophobic? Are you afraid of heights? Because just because you're standing at ground level, I have seen spaces that are extremely deep with very hard to get into. And we're also going to talk about the safety things that are happening out there, okay? What is there about this space or the area or the general area around the space that could hurt you? Okay, let's move on to next, please. So the confined space assessment, we're going to be assessing, for the most part, you may have something different that you may need to test for in your spaces, but usually we're testing for oxygen levels, lower explosive limits, carbon monoxide, and hydrogen sulfide are our main atmospheric hazards. Chemical hazards, is it corrosive? Is it oxidizers, toxic? And physical hazards, heat and cold. Are you working outside? Are you working inside and it's an extremely hot day or an extremely cold day and you don't have heat or air conditioning in the building? Noise, if you, let's say you're building a heat exchanger, for example, and you have to climb in there to weld and grind, there's going to be a lot of noise happening in there in that very tight space that you're working. You're going to be affected by vibration as well. So those all need to be taken into account. Biological hazards, viruses, bacteria, mold. You could have a chiller, for example, that if you haven't done maintenance on that chiller in some time, could contain Legionnaire's disease. So things have to be taken into account and we have to think about those. I talked a little bit about the musculoskeletal disorder hazards, psychosocial hazards, safety hazards, all of the energy that can be built up in a confined space has to be dealt with. It could be electrical, it could be kinetic, so on and so forth. You have to make sure that you are looking after those, the energy, the slip, trips, and falls, all of those things that could happen. Configuration hazards, slope, compartmentalized, obstructions, all of those things in that space need to be addressed, and the content hazards, residual engulfment, entrapment. Is it possible that there could be an inrush of water coming into this space? And then we deal with the external hazards, which is traffic, weather, terrain, animals, and all of those things. Let's move on to next, please. So atmosphere is responsible for 80% of the deaths in confined spaces. You can't see or smell most toxic gases. You can't determine the level of oxygen present. Going back to the can't see or smell, carbon monoxide, you have no idea that carbon monoxide is around you because you can't see or smell it, and there's many others out there that will do the same thing. There could be different hazards at different levels, and you take a look at the picture on the right of this slide, and you can see that up top the air looks quite clear, but as you go down you can see some clouding happening there. And one of the things that will happen, and H2S is a very good example of this, when you first are exposed to H2S, you'll get a really strong rotten egg smell. And very short time down the road, your senses become fatigued, and you're not going to be able to smell it anymore. That doesn't mean that the hazard has gone away. That means that your sense of smell has gone away. So we have to rely on remote monitoring or four-gas monitors that an entrant has got it connected to their harness so that they know very quickly if there is a atmospheric hazard within that space. Okay, let's go on to the next one. And you can see here is some of the hazards that we would be looking for, okay? And so we're looking at the atmospheric hazards. All those hazards that I listed off are there. And when we go through and we have determined that there's a hazard, let's say that we could have a low oxygen situation, okay? And so if we say that there could be a low oxygen situation in the atmospheric hazards, we're going to note controls there so that we're able to make this space more safe. So for example, we could be adding ventilation controls to that. We could be purging the unit or whatever it takes to make that space safe. But it's very important to ensure that you have those controls in place before anyone enters. And next, please, Troy. So we talked about quickly how we can get through doing the hazard assessment. We've talked about a program, hazard assessments in place. Now we're going to start working on an entry plan. And the entry plan is going to talk about what the entry team is going to do, the duties of each person. Okay, we're going to talk about the coordination of contractors and what's our on-site rescue procedures look like. Do we have an in-house group of workers that have been trained in confined space rescue for your confined spaces that are going to be there in the event of an emergency, so they can come in and help? Are we bringing in a third party to do confined space rescue standby, which is an option? And what does that rescue look like? So that all those plans have to be in place before anyone goes into that space. We also have to know what equipment do we need? How are we going to communicate? For the equipment, some examples of that would be a davit arm, a tripod, an SRL with a recovery unit. We could get into mechanical advantage systems using ropes and pulleys, various other types of equipment. And how are we going to communicate? Usually we like to have the attendant communicating verbally with the person, but if you're in a space that is fairly large or it's in a noisy area, you need to come up with different ways of communicating. So that could be through a radio, could be a cell phone. All that has to be decided and recorded on your entry plan, how you're going to do that. The PPE that you need when you are entering those spaces. What do you need for PPE? What's the clothing that you need to wear? What devices do you need to take with you? We always recommend that anyone that is entering a confined space is entering with a full body harness that's connected to an SRL with recovery. The reason that we request that, or that we recommend that, is simply for the fact that if the person that's entered has a medical issue or any issue whatsoever, the attendant can start to crank the person out using the recovery portion of the SRL, and start the rescue that way once they've called 911 and alerted everyone else that there's an issue happening. That is the ideal entry, and there's some cases where that person cannot be tethered. If the person cannot be tethered by their harness, we recommend that you have a rescue team on standby at the space in the event of an emergency, because that rescue team is now going to have to go in and recover the entrant that's gone in there. And we're going to talk about some of the things to look out for when we get into the rescue portion, okay? We also have to isolate the energy, lockout, tag out, whatever it's going to take to make that space safe for a person to enter. We also have to control material movement. So thinking about a silo, we have to make sure that if someone is going into that space, that they're not going to be put into a position where they could be pulled into that grain and that kind of stuff. We have to watch for those things. And next, please, Troy. So the entry plan, it's got to be adequate means for entering and exiting. All right. And the adequate means for entering and exiting is, this person can get in and out of the space under their own power. What happens if they can't get out of the space under their own power? So we have to think about that as we're developing these entry plans. If we get a spot where someone has gone into a space, and we can't get them out safely and easily, we have a problem. That person should never have gone into that space if we don't know how we're going to get them out of there safely. Okay. We have to do atmospheric testing. Atmospheric testing is one of the very important parts of confined space entry. The atmospheric testing is going to be done on the space in its as close to its normal operating condition as possible. So, for example, if you are testing a tanker truck prior to entry and it's got 4 or 5 compartments in it, we're going to open each compartment just enough that we can do atmospheric testing so we can get a reading at its normal operating condition. Then we'll move on to the next space and do the same thing. It is very important to have a good understanding of what's in that space and how it's operating before we go into it. So let's say that we've got a space that has a high level, let's say 100 parts per million of carbon monoxide in it when we're doing the initial testing. That's telling us that we're going to have to ventilate or purge that space before they go into it, okay? And if we're going to be going in and doing hot work, we have to make sure we've got adequate procedures in place for that hot work. And so basically what we're doing on the entry plan is we're breaking that down step by step of how we're going to do the work safely and efficiently. Okay, and we'll go on to the next one, please. So the controls we're going to do, we're going to lock out all energy sources. Okay, lock out, tag out. That could include movement. That could include air pressure. That could include all different kinds of energy that's out there. We're going to empty all the contents of the space. Going to sample the air. Then we're going to purge and ventilate. Set up the appropriate equipment, retrieval equipment, and ensure that there is rescue available. Okay, and as I said earlier, the rescue could be workers trained at your place of employment in rescue using your spaces, your equipment, and they're going to continue on with their normal duties during the day, but they're going to have been advised that we have a confined space entry going on, and you may need to be attend the space in the event of an emergency. And that means that the person is, the rescue team is going to be familiar with the equipment. They're going to have it set up at the space, ready to go, so that there's no delay in initiating the rescue. Okay, so, and there's a lot more to it than that, but we have a very short window here today to talk about this. So the big thing to remember is go through, plan the work, and then work the plan. Okay, let's go to our next, please, Troy. All right, so the role of an attendant. An attendant shall not enter a confined space. Okay, there always has to be an attendant in place, even if there is a rescue taking place. There always needs to be an attendant. They have to be outside of the space, stationed outside and near the entrance. Okay. In Ontario, there is not a way of using remote monitoring for an attendant. The attendant must be in the vicinity of the space, near the entrance, and monitor the safety of the worker inside. They're in constant communication, and that means that they're able to see the person. If they aren't able to see the person, they're going to be talking to them on a regular basis. Constant communication doesn't mean you're going to be talking the person's ear off. It's just every predetermined amount of time, be 1 minute, 5 minutes, whatever you decide in your plan, you check on that person to make sure that they're safe and working well in the space. And the attendant is going to provide assistance during rescue. And a non-entry rescue, if the attendant realizes that the person is inside is having trouble, the first step they want to take is, hey buddy, come on, get out of here. Something's going on, need to get you out into fresh air. That is the first step of a rescue. That is a self-rescue of the entrant, okay? And we're going to talk about the different types of rescue, the 4 types of rescue as we go along here this morning. So provide assistance, never entering the space, so turning the crank on a winch, calling for help, whatever that assistance looks like and is laid out in your entry plan and the rescue plan, and provided with a communication device to summon rescue. And you know, that device could be a radio, could be a telephone, could be a cell phone, smartphone, whatever is you decide to use for your communication, you have to make sure it's there and ready to go. And let's go to the next slide, please. So we need to assess the atmosphere. That atmosphere is going to be assessed by a gas monitor, by an air monitoring piece of equipment. We recommend that you're using 4 types of gas monitor. You may need one that has more than 4 types of gas, depending on the application and the space that you're going into. And that would be determined by your hazard assessment. And just before I get too far, we do a lot of hazard assessments for our clients. And I by no means know what it takes for a welder to make a heat exchanger, for example. I know what a heat exchanger looks like. I have no idea how to make one. So when I'm doing those interviews, I make sure that I have a competent person with me that understands the processes that take place within that confined space. That way we're able to ascertain what are the hazards in there, and we can record those findings. Okay, so assessing for oxygen, lower explosive limit, toxic gases, carbon monoxide, H2S, and you could have others. And it is absolutely necessary that you assess that space prior to entry. And depending on what you find in that space, you could be, or the work that's being done, you periodically can assess it during the entry. But we recommend that the entrant has a monitor connected to their fall arrest harness so that they're able to test the air continuously while they're in the space. Also, there could be irregular features within that space, corners, bulkheads, different levels. You may be going up, maybe going down within that space. And you need to make sure that you're checking all of those spaces, because there could be dead air spaces where there's a buildup of toxins or a lack of oxygen. Okay, and let's move on to the next. And another poll. So what is the normal concentration in air? Okay. All right. So answer to that one is 20.9% oxygen in the air is a normal atmosphere. Unless you're using an MSA gas monitor, and then it's 20.8, but that's just a little thing that I've found over the years. Okay, so let's move on. What's an acceptable atmosphere? Okay, go ahead, Troy. 20.9% oxygen in the air, and an atmospheric hazard and not an acceptable atmosphere if the oxygen level is less than 19.5% or more than 23%. All right, so let's move on to our next. So what's an acceptable atmosphere? Slide 2. So we have to take a look at our explosive or flammable atmospheres. So it's measured in a percent of the lower explosive limit, or the LEL. Okay, so what that's saying is if we are measuring the space, we are measuring the lower explosive limit. So to do visual inspection work, it has to be less than 25% of the LEL. Cold work needs to be less than 10% of the LEL, and hot work needs to be less than 5%. You have to do continuous air monitoring, atmospheric monitoring, continuous mechanical ventilation, and you have to have a fire watch in place with suppression equipment. So hot work, you may be doing a hot work permit along with your confined space permit for someone that's going in to do work in a confined space. Okay, let's go on to the next one, please. So toxic atmospheres. So acceptable exposure limits for toxics in confined spaces are set out in Regulation 833. And you can also find that in a little book that looks something like this one here. All right, and the ACGIH TLVs, and that lists all different kinds of exposures to biological chemical agents. So our gas monitor is going to be set up so that it goes into alarm at 25 parts per million. And, you know, that is fairly low because when the alarm is going off, it's warning us that something is building in the space and you need to get out. Big thing to remember, if you go into a space, gas monitor is going off, get out immediately, okay? Because you don't know how fast that space is filling up. And hydrogen sulfide at 10 parts per million. So you need to know what could be in the space before you assess it. And again, going back when we're doing confined space assessments for clients, we make sure that we have a knowledgeable person with us about those spaces so that we're able to ask those questions to ensure we're doing a adequate and a good adequate hazard assessment. Okay, next please. So we also have to control material movement in those confined spaces. So the way we do that, we need to remove the liquids or free-flowing solids. And this silo here is showing, a really good example of a free-flowing solid. It looks to me like it's corn in this bin. And if you look, you can see that there's a bridge across there. And if someone was to climb into that space from the top, walk across that bridge, what's going to happen? Okay, bridge could break and they could be pulled down into augers, could be pulled into machinery that's moving that product through there. So you have to be extremely careful in dealing with these. I was visiting a client and they told us a story about a contractor that they had to come in to work on their silo. The silo was roughly 30 meters high. The contractor came in. They had to go in and replace something on the inner roof of the silo. So the contractor came in, climbed up the silo, went into the silo, stood on top of the product, did the work, came down. The manager walked up, manager of the property walked up and said, okay, guys, you ready to start work on this? And they said, no, we're done already. And the manager opened the bottom of the silo. The silo was empty on the bottom. These guys were 30 meters in the air, standing on a bridge of corn. And luckily it held them, but always look at the bottom of the unit before you start going up top to see what's happening. So it has to be secured to prevent movement of free-flowing solids or hazardous materials. Okay, next please. So we're going to control the hazardous energy. It's going to be disconnected from its power source, either real or residual. We're going to be securing the machine or device in a de-energized state, and we're going to put a lock and a tag on it so that we have isolated those spaces. Okay, and it's not necessarily just electrical lockout that we're doing. We may need to lock out valves and pumps and other things that are connected to that space. All right, and those need to have a lock put on them. And it's very important that this happens because if you're in a space and someone walking past a fuse panel or a switch and sees that it's shut off without a tag or anything, going, wonder why that shut off, and turns it on. We just had an incident happen, okay? So let's move on to our next slide, please. So I see we've got a bunch of questions coming up in the chat, and we'll get to those when we get through the slide here. We should have a bit of time at the end of the day. So it's very important that you have an adequate means of entry and exit. There has to be, the opening has to be large enough to allow safe passage of a person wearing their PPE, the required PPE, and make sure that they have the protective equipment that they need to do the work. And it includes emergency equipment to be used by a person who takes part in a rescue, all right? So it's very important that we have a way of getting a person out of those spaces and saying, okay, well, we'll just grab the person and we're going to lift them out. Grabbing a person and lifting is not necessarily the best way of doing the work, and it may not be the safest. So it's very important to make sure that you have an adequate means of entry and exit, and before you start doing work in that space, make sure you've practiced it so that you're able to get in and out. One of the assessments that I was working on yesterday, the access port to this space was not large enough for a person to bodily enter. Okay, so if you can't get into a space bodily, into that space, yes, it's a confined space, but you can't do any work in it if you can't get into it. Okay, let's go on to the next one, please. All right, so with our hazard assessments, we're going to be putting under additional controls and or recommendations. That's where we put our means of entry and exit. Okay, and we may put in things there. For example, we may be going to an employer and identifying all of their hazardous or all of their confined spaces, and their employees will never enter those spaces. So in that additional hazards or controls, we're going to note there that this is a confined space, but there has not been a hazard assessment conducted on this space, and there must be a hazard assessment conducted before entry is made. All right, so if you're relying on contractors to come in and do your confined space entry work, and your program is set up in such a way that you do not enter those spaces, it's going to be up to the contractor and yourself to make sure that they've assessed all of the hazards in that space, designed an entry and exit plan and a rescue plan with rescue team on standby, or what their rescue is going to entail. Okay, and let's go. Something else that I'd like to point out, we'll go back one, please, Troy. Also, all of our work that we do, when we go through and do hazard assessments, for example, I'll go in and do hazard assessments, then I send that off to another subject matter expert in confined spaces, which is Craig Stewart, who I work very closely with. And we review each other's work to ensure that we've got adequate entry-exit plans, and we've done a very good job for our clients. And on to the next one, please. We're going to talk about entry permits. Okay, confined space entry permits have to be issued before each entry. It's got to be readily available at the space. It's going to set out the measures and procedures to be followed. There's going to be a record of the entries and the exits, and also the results of atmospheric testing. We'll go on to the next slide, and this is what a confined space permit is going to look like. Ours are 4 pages long because they have adequate space for multiple entries, multiple people entering. So there's mostly charges, mostly spots for recording those entries. Okay. Let's go on to the next one, please. So let's do poll number 5. We'll put that one up there, please, Troy, and let's talk about is relying on 911 services for confined space rescue considered an adequate plan? Let's see what we get for answers here. All right. You know what? It looks like everybody has got the right answers here. Okay. And let's go on to the next slide, Chad or Troy. And a rescue plan does not equal 911. And the reason for that, and this is by no means anything against any municipal fire service, but there are a lot of fire services out there that are not trained in confined space rescue. They will, as part of their certification, are going to have awareness training on confined spaces, and some departments may even have confined space or technical rescue teams. But for the most part, fire departments aren't trained or equipped to do confined space rescue work. So the law requires you to have confined space rescue available for immediate implementation. Some of the numbers that I've heard out there is a municipal fire department, and any municipal fire department, this is averages, take anywhere from 81 to 151 minutes to recover someone out of a confined space from the time of the call until the time they get there. And the reason for that is firefighters aren't just going to jump in and get someone out of a space. They need to make sure that their people are going to be safe. So they have to assess the space. They have to do everything that you have done to get that person into the space. They need to do that before they can put their rescuers in. And it may not be as complicated and as official as the hazard assessments that I've been showing you, but they are going to be assessing the hazards to make sure that they aren't going to hurt anyone else. Okay, so let's move to the next slide. All right. So rescue has to be ready for immediate implementation at the space. And that comes right from the Ministry of Labor Confined Spaces Guideline. Emergency services do not replace a requirement for on-site rescue procedures. There are several companies out there throughout the province that provide confined space rescue standby and many services. Okay. So the rescue plan and the procedures have to be written, okay, and ready for immediate implementation. There has to be an adequate number of trained workers available immediately, and there has to be first aid and CPR trained workers as part of that team, okay? And the rescue equipment that you need, it's going to be as pointed out by your hazard assessment, okay? Harnesses, mechanical advantage systems, patient packaging, supplied air systems, SCBAs. You need to make sure that you have a plan, the equipment, the personnel, and the training in place before anybody goes into those spaces. And we're also going to practice those the rescue plan to make sure that we can get someone out of there in the event of an emergency. And next, please. Okay, so we're going to talk about the types of rescue. Type 1 rescue is a self-rescue. And I'm proud to say I've got a few of these saves under my belt. And simply from being an attendant at a confined space and the person's alarm is going off, their gas monitor is going off, and it's, hey, get out of there. That's a rescue. That person just climbed out of there, got out on their own. Okay. And, you know, it could be the attendant encouraging them, move towards the opening, keep coming, I got help on the way, talking to them, that kind of stuff. Let's go on to next slide. So there's going to be a warning system in place. And that warning system, I talked about the gas monitor alarm going off. We also need to have a warning system in place to alert the rescue team if they aren't right there at the site, okay? You know, is it going to be an announcement over the PA? Do these rescue workers carry radios with them? So the event of emergency, they're called on the radio and asked to respond. Is it a phone call? Is it a text? All that stuff, that warning system has to be in place. Excuse me. And the entrant can get out of the space unassisted, and the pathway is always negotiable. So there hasn't been a collapse. There hasn't been something that is compromised the exit pathway. All right, let's go on to the next. And type 2, which is a non-entry rescue. So the entrant is not able to get out on their own, and you can move to the next slide, Troy. They can't support their body weight, and that could be because of lack of oxygen, could be a toxin that they're becoming overcome with. You know, it could be overexposure to oxygen, and, you know, depending on what's happening there, that person may need assistance. They may have injuries that require stabilization. So if someone has gone into a confined space, slipped, tripped, and fell, and have a neck, back injury or some type of injury that requires stabilization, that person may need to be packaged within that space. And there's all different kinds of equipment to use that. There is skeds, Stokes baskets, backboards, all different kinds of equipment that could be used for that. But you need to make sure that you choose the right equipment while you're doing your entry and rescue planning. Okay, so the entrant can be continually talking to the attendant. The retrieval system should have been set up prior to entry, and hopefully that system was was set up, and the entrant was attached to the retrieval system, or at least a lifeline that could be connected to a retrieval system to winch that person out or crank that person out. Okay, so that is where we are turning a crank, pulling someone out to get them out of their, assist them to get out of the space. And let's move on to a type 3. Okay, and type 3, I got ahead of myself on the type 2 a little bit, but you can see in the picture on the right here, that's a person packaged in a sked. We've got the person on the left here is packaged in a half sked, or a spec pack is another name for that piece of equipment. And let's move on to the next slide. So if the entrant is untethered, somebody has to go in and connect a retrieval device to that person. Okay, their injuries are going to prevent them from exiting the space unassisted. There can be configuration hazards, uneven floor surfaces, internal obstructions, long traverses, the angle of travel. So if you have someone that is off to the side, you've got a tripod set up, and you start to crank the retrieval device on a tripod. If that person is outside of the footprint of the tripod, it could cause that tripod to collapse. Okay, so you have to make sure that you're pulling straight on tripods, or you have redirects in place wherever you can't. All right. And the next one that is very important on a entry rescue is there's a gas detector in the space that's not in an alarm, or the entrant is conscious. Okay, so if that's telling us that we have a safe atmosphere that we're entering into, we've got good ventilation going on, and the person has sustained an injury or a medical issue not related to the confined space hazards, I guess, for lack of a better term. All right, and let's move on to a Type 4 rescue. Type 4 rescue is an entry rescue, very complex, and it's in a immediately dangerous to life and health situation. And so the Type 4 rescue covers all of the things in a Type 3 rescue, but the entry point is obstructed or at height. So maybe you've got to go up some scaffolding to get up into the space. All right. The gas detector in the space is in alarm. Okay. If the alarm is going off in that space, you can't go in there without protecting your respiratory system. Or if the entrant has a decreased level of consciousness, or you didn't see them collapse. Okay, the attendant didn't see them collapse. So we have to make sure that we're going in. You could be going in on air, and anyone that has used an SCBA going into tight spaces knows that that does present some of its own challenges, as well as supplied air systems also have a few challenges with them, where you have tethers connected. You have an escape bottle on them, which is going to increase your size going in through those openings. So it's very important that Type 4 rescues, all types of rescues are practiced and trained to. Okay, and next please, Troy. So here's what a rescue plan can look like. The rescue plan is going to be set out check boxes for the equipment that we need. How many people are we going to need to do it? It explains where the site is, entry portal size, the number of entry portals. Do we require rescue on standby, or do we require them at the site? How are we going to communicate? And the external environment around you, what is there that could cause us issues? What could hurt us? Okay. What type of rescue are you going to be doing? Are you doing a are you doing a horizontal entry, a vertical entry? Are you hauling? Are you lowering? Do you need a mechanical advantage systems pre-rigged so that you're able to lower someone? All of those things are covered on here. And then when you get to the plan of action, we're going to go through and step by step how that rescue is going to work. Okay, so I've taken you through very quickly on what the confined space program, all the components of it, how to work safely in confined spaces. We've just scratched the surface here on a lot of the hazards that we can run into, a lot of the entry problems we can run into, and the rescue problems we can run into. So how can we at WSPS help you? Okay, we can come in and do confined space identification. We can develop programs, hazard assessments, entry planning, rescue planning, and we do instructor-led um, confined space safety programs. We have a couple of confined space e-courses, and we have a confined space entry and or rescue practical training, which is instructor-led, that is can be anywhere from half a day to 2 days, depending on the level of complexity in your confined spaces. So our confined space team, we have myself and Craig Stewart. I'm located in the Windsor area. Craig is in the Kitchener area, and we cover the whole province, and we have been to quite a few other provinces across Canada doing work for them. So that's the presentation. And Troy, do we have any questions that we can?
We certainly do, Dale.
Okay.
I'll just start off kind of from the bottom and work my way back up because some were answered earlier.
Okay.
So last one that came in is, what is considered an entry? Our procedure states entry is the ingress of a personnel into a confined space upon breaking the plane of the confined space opening with his or her face and all periods of time in which the confined space is occupied. On the ministry side, it states an entry is an action that is considered to have occurred as soon as any part of the entrance body breaks the plane of an opening into such a space, regardless of whether the intended work activities may or may not require whole body entries, such as atmospheric testing.
Okay, and that's a very good question, because we run into this on a fairly regular basis. So as on any confined space in Ontario, as soon as you break the plane of that space, and the space has to be large enough that you can bodily enter. Okay, so real quick example is if you have a machine where that is designated as a confined space, and you have to go into that space to replace components of the space. You have to bodily enter that space. That's a confined space entry, where you have to remove a panel to get into the space. That panel that you removed, if it is just large enough for a person to reach in, take a sample out of that space, under the ministry guidelines, that's not considered a confined space entry. Okay, because the person cannot bodily fit into that space.
Okay. Yep.
So that's the answer in Ontario.
Perfect, thank you. Another question here. I understand that there are some changes proposed for confined space attendants, which will allow an attendant to watch over multiple confined spaces with the use of technology. Apparently, these changes may be tabled before the end of the year for Ontario. Do you have any information on this?
No, I do not, and I would like to get some information on that. I know that Alberta recently changed their regulations that allows for remote monitoring, and there is a few things that are associated with that, and it's been a couple of weeks since I've looked that one over. Not 100% sure what all of those are, but that person, the attendant, has to ensure that they're watching that person continuously.
Fantastic, thank you. Next question. If there's a fatality in such an environment involving a contractor, can the employer be held accountable if they have verified that confined space systems were in place?
That's a very good question, and you know what? I can't answer that one 100%, but it depends on what comes out of the court cases that happen there. Okay. You know, the employer could be held responsible because the contractor would be treated as an employee.
Okay. When maintenance contractors are entering confined spaces, whose program should be followed, the owners or the contractors?
That's a really good question. The owner of the space needs to have a program in place. And if their program does not permit their employees to enter that space, the contractor coming in will need to have a program in place on how they're going to enter and deal with those confined spaces. And the one that pops into my mind is a municipality where they have storm sewers and storm drains and sewer systems, and their employees don't enter those spaces. That may be their policy, their program says we do not enter those spaces. The contractor coming in will then need to have a program in place for assessing entering and rescue on those spaces.
Okay. We have contractors are entering, working in a tank, and I isolate all the lockout, all the process pipes leading to and away from the tank, followed by contractors doing lockout. In this scenario, do we need to complete a coordination document?
Yes, there should be a coordination document in place to make sure that you understand who's responsible for what.
Okay, fantastic. If a space is engineered with ventilation system with adequate air exchange, would it still be a confined space?
No, and that's a real good thing to remember. If you are working with additions on buildings and things like that, the best time to deal with a confined space is during construction, so it is not a confined space. Real quick example of that is I've been to machine shops where they have access to presses. In the old section of the building, you had to go down a fixed ladder through a manhole, maintenance access cover to get into that space, and it was a confined space. And the new portion of the building, it had a man door, it had stairs, it had lights, it had gas monitoring and ventilation. It was not a confined space. So
Okay.
It's best to design your spaces so they are not confined spaces.
Okay, we got two more here to go. What if there is an asbestos insulation above a drop ceiling and you're going to enter into that drop ceiling? Are there potential airborne asbestos fibers considered an atmospheric hazard? Would it be deemed a confined space?
If you can bodily enter into that space, yes, it would be a confined space, but you're also going to be using the regulations dealing with asbestos removal or working with asbestos.
Okay, fantastic. How do we check welding hoses for leaks? What is the process for testing? Can you provide one if you may?
Soapy water. Give them a spray with soapy water to check all your connections. Make sure that they aren't leaking.
Okay. One more here. So it says ACGIH 2023 says the time weighted average of 1 part per million and STEL of 5 parts per million for H2S. Can you explain the TLV of 10 parts per million?
At this time, no, I can't, unfortunately.
Okay, we can certainly
have to get back to.
Okay, fantastic.
Can you do it, Troy?
They're referring to different time frames, right? So the time weighted average would be over an 8-hour period or a longer period, whereas the short-term exposure limit is 5 parts per million. And then ultimately the threshold limit value, which is the maximum there, would be the 10 parts per million. But we can certainly get more info on that in the future. You can certainly reach out. That does bring us to the end of the session. We did go over by a couple of minutes there. We appreciate your patience in there. As was mentioned at the beginning, we will follow up with some resources based on this presentation. So please keep a lookout for that. Once again, I would like to thank you all for your participation and engagement on the subject. And hopefully we see you again in another WSPS Safety Connection. Thank you and have a great rest of your day.
Thank you, everyone. Have a great day.